Electric linear actuators are designed to handle loads axially. One of the most common failure modes of a linear actuator is the result of side loading. A side load occurs when a force exists that is perpendicular to the axis of rotation. The basic design of a linear actuator includes a motor, gearbox, and ball or acme screw assembly. In this case, the axis of rotation would be the ball or acme screw assembly inside the extension tube. The longer the stroke, the more susceptible an actuator will be to binding or potentially a bent screw. Although these units are not designed to handle a side load or extreme shock load, there are ways to improve the rigidity of your linear actuator design. For example, a heavy wall cover tube or heavy wall extension tube can be used to beef up your solution. As you can see from this side-by-side comparison, the difference is minimal, but the result can be significant. Increasing the diameter of the ball screw is also a way to improve rigidity. A common ball screw diameter for a linear actuator that can push or pull 1,000 pounds or 4.5 kilonewton is 5/8 inch or 16 millimeter. Increasing the diameter just up to 3/4 inch or 20 millimeter can enhance rigidity. This nut guide can be added for additional load support on the ball end itself. For longer stroke lengths, a double wiper design can be used to increase the rigidity of a solution from sudden shock load. In this case, we have a wiper at the end of the cover tube and an additional wiper about 3 inches down the end of the stroke. The more space between wipers, the more rigidity the actuator will have. So, next time you're specifying an electric actuator, keep these tips in mind to ensure the most rigid solution for your application.